Okay, good afternoon, everybody.
Good afternoon.
Okay, what I want to do today, I want to do one more example of the multiplication. Then I will do the multiplication with signs. Then I will do the parallel multiplication. These are the three, and that will do our arithmetic logic unit, at least for the adders and multipliers. Okay, so let me just here introduce a table for me. I want to multiply these two numbers. 7 times 10, it should be equal to 70. This number here on the right-hand side in binary, this is 70. If you count, this is the first one is 60. 64 plus 6, that's 70. So this should be the correct result here. Example. Okay. Just and I will do it two ways. One, I will switch the multiplier and the multiplicand just to make sure that everything in our system works as needed. Okay, oh, I can insert a table. Yeah. Okay, so this is I'll start from here, my partial product. This is my multiplier, and this is the operation, and the last one here is the sequence number. And here I have my multiplicand. So my multiplicand, let me start with the make it this way. So my multiplicand, I will do the 0, 1, 1, 1. My partial product is 0, 0, 0, 0. And my multiplier is 1, 0, 1, 0. So 10 times 7 should be. So the first thing, I will take the least significant bit, which is 0 in this case. Okay. Second. Okay, so my multiplier is 1, 0, 1, 0. The first operation, because it's 0, this will be shift only. Shift operation, I don't have an add. This is my sequence number 1. So if I do the shift, now this here will become, I will get the 0 from here. So this is, I'm shifting this guy. Okay, so here I will have now my 0, 1, 0, 1, and this 0 will go out, so this will disappear, and my partial product continues to be 0, and my multiplicand remains 0, 1, 1 because we don't change the multiplicand. So now I go to next operation, 2, here, because the first one is the most significant bit is a 1, so I'll do an add. So this will be an add, which means I add the multiplicand here, multiplicand plus PP. So it's a multiplicand plus PP. And let me do it this way. Okay. So I do the add. So I do the 0, 1, 1, 1, and the result I'll do it this way is going to be 0, 1, 1, 1. So that's my result. And then I will do a shift. Once I have the result here, I will do the shift operation because this is add plus shift. So now this remains, it was 0, 1, 0, 1. Now I will shift all the result. So this becomes 0, 0, 1, 1, and that one goes here. So this is 1, this 1. Okay, so this one goes here, and this guy here will shift the 0, 1, 0, 0, 1, 0, and the one that this one goes out, disappears, the red one. So now I am at operation number 3. So I'm done with operation first. I get the first 0, then I get the 1. Now this is only a shift, so I don't have to do anything else. So if I do a shift here, so this shift will shift this 1. So I have the 1 here, 1, 0, 1. Okay. Now, so this is my red guy here. That's the, oops, that's the one that allowed me to do uh, my shift operation. So this is done now. And here this will be 0, 0, 0, 1. Okay, now the last one, my last operation, is going to be an add. This is the one which is an add. So I'll say add. Again, multiplicand plus PP. Now this is my multiplicand, still 0, 1, 1, 1. We don't change that. And this one was 0, 1, 1, 1. The multiplicand does not participate in the operation except in the add. So now here 0, 1, 1, 1. Again, I will add it to this. So I'm adding 0, 1, 1, 1. If I add this number, we'll go from the right to left. 1 plus 1 is a 0, plus 1 is a 0, plus 1 is a 0, and then 1. So it's 1 plus 7. It's actually 8. 1, 0, 0, 0. And this comes down here. It's 1, 1, 0, 1. Now I will have to do the shift after the add. So this is a shift. This shift with step number 4 goes with this. So the shift the 0, 1, 0, 0, and the last 0 will go here. And this is 1, 1, 0, 1, 1, 0, yes. And this one will disappear. So this one disappears. It's part of the... So if I look at the result now, of course, this is reached 4.